All right, so we want to look at how we factor when A, our leading coefficient, does not equal 1. So whenever you're given a expression to factor, the first thing you want to see is, can I factor out a greatest common factor? But since there's a 5x squared minus 13x, those don't have anything in common. So we cannot factor out a GCF. So I'm going to do this same problem 2 different ways, and then you can choose to do these in the way that makes the best sense for you. So the way I like to do it is the same way as when A does equal 1, with just a little twist at the end. So I start here with my 5x squared, and I put down my 2 parentheses, and I know that I need to have a 5x times x in order to equal 5x squared. Then the second place I look is over here at my last term, and I have a 6. And so I write down my factors of 6, 1 times 6 and 2 times 3. It's a very short list. Then the third place that I come and look is my signs. Put a 3 here. So since my last term is positive, I know they either need to both be positive or both be negative. But then I see that the middle term is negative, so that tells me that they're both going to be negative. And then the final place that I look, right here, step 4, is that negative 13x. Now, in our other types of problems, when I just had an x here and an x here, then all I had to do was look on my factor list and find things that added up to 13. But here's where the twist comes in. Because one of the numbers is going to get multiplied by 5, but the other number is only going to get multiplied by 1. So I have to keep that times 5 in mind. But I have a very short list of possibilities. So I just kind of plug them in. If I put a 1 here and a 6 here, then 5 times 6 is 30. Okay, yeah, that's way off. Well, what if I put the 6 first and the 1 over here? Well, then I'd have 5 times 1 is 5, but then I'd have 6, that would be 11. So this does not work either way. So then I try the next factors. If I put a 2 here and a 3 here, the 3 would go times 5, which would be 15, and the 2 would go times x, but they're both negative, so I'd add those together, that'd be 17. So I only have one choice left, so it's going to have to be a 3 here and a 2, and then watch what happens. 5 times 2, I've got negative 10. Negative 3 times x, I've got negative 3. Negative 10 and negative 3 is negative 13. So ding, 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 that's my right factors. So just to make a clean copy, 5x minus 3 times x minus 2. And of course, I can always go back and distribute to check that I am correct. Well, another way, we're going to take the same exact problem and we're going to work this out by grouping. And you learned this method in Algebra 2, and so some of you may have really liked this method. It's a good method. I just think it takes more writing. So personally, I like the top method better, but it's your personal choice. So how do we do by grouping? By grouping, you start with your A and your C. So AC, you multiply them together and you get 30. And then you write down your middle term, which is called b, and that's a negative 13. And so now you're looking for two numbers that are going to multiply and make 30, and at the same time those numbers are going to add to make negative 13. And you might just think of them off the top of your head, or you might start to make a list. 30. 1 times 30. Does that add up to 13? Nope. 2 times 15. Now, if they're both negative, does that add up to 30?
Yes.
If they're both negatives? No. What about 3 times 10? If they're both negative, right? So what we really need here is negative 3 times negative 10 to make positive 30, and negative 3 plus negative 10 to make negative 13. So now what do we do with that negative 3 and that negative 10? What we're doing is we're going to take this negative 13x and we're going to break it up into two groups. So I'm going to write down 5x squared plus negative 10x plus negative 3x plus 6. And you could write it as just minus 10x or minus 3x. But then what we're going to do at that point is we're going to look at these two groups. So we're going to group our first terms together, then we're going to group our second two terms together. So in my first two terms, what's my greatest common factor? Just in the blue part. 5x. So in the blue part, I'm going to factor out a 5x, and I'm going to be left with x minus 2. Now in my green part here, I want to have a positive x, so I'm going to factor out a negative 3. And if I factor out a negative 3, I will have x minus 2. And it's always going to happen that way. So now, do you see we have two terms? This is term number 1, 5x times x minus 2. This is term number 2, 3 times x minus 2. Inside these two terms, they have a common factor. So we are now going to take that common factor and factor it out. So I get my common factor of x minus 2. Keeping in mind, when I factor something out, I'm actually doing division. So if I take 5x times x minus 2 and I divide by x minus 2, what I have left is 5x. If I take my second term, negative 3 times x minus 2, and I divide by x minus 2, what do I have there? Minus 3. So those are my factors. Compare that with our other answer. Same answer, right? So if you learned factor by grouping last year and you became proficient at it and you're really good at it, it's going to work. And it may be easier for you to brainstorm this than the other way. Personally, I like this way best, especially if there's a few things. So if this number here, this 5, if whatever number's here is a prime number, 2, 3, 5, 7, this method is really not that different than before because you know a 5x has to go here and you know an x has to go over here. Now, if this number in front is composite, like if that 5 right there was a 12, then I might do grouping. Because if that's a 12, I don't know if it's going to go 2 times 6 or 3 times 4 or 12 times 1. Now I have lots of possibilities. And so this method might take a lot of guessing and checking. But if that first number is a prime number, then I think this way is pretty simple. That's my personal opinion.